Welcome to qnawire.
So the addition of diphenyl to benzene changes the vapor pressure, the melting and the boiling points that move away from the standard values that we would otherwise see for benzene. So we have a mass of diphenyl, it's 56 grams, a volume of benzene, 550 mil, density in the molar mass of benzene, 0.879 grams per mil and 78.11 grams per mole. So the first thing we can do here is calculate the moles of each component by using the mass and molar mass. So moles of diphenyl is equal to MD over MWD, 56 grams by 154.2. We get a value of 0.363 moles. We do the exact same thing for benzene. We get a value of 6.189 moles. So following this, we can take a look at the molar fraction of diphenyl in the solution. This is the ratio of moles of diphenyl to the moles of diphenyl and benzene. So we have XD is equal to ND divided by ND add NB. We can calculate this to be 0.0554 moles of D per mole of solution. So the vapor pressure of the solution is approximately equal to 0. It's equal to the effective solvent vapor pressure, which is the molar fraction times the vapor pressure of benzene. So PB at 30 degrees C is equal to XB multiplied by PB at 30 degrees C again. So what we have is that's equal to 1 minus XD multiplied by PB star 30 degrees C, so that's equal to 112.6 millimeters of mercury. So moving on to the next part, so for dilute solutions, the expression of the boiling elevation can be used. We have delta TB is equal to RTB naught squared over delta HV hat for an operator XD. So we can determine delta TB, that is 1.86 Kelvin, 1.868 Kelvin. So we've calculated the boiling point elevation. So the boiling point of the solution is the sum of the boiling point of the pure solvent at this elevation. So we have TBS is equal to TB naught add delta TB, which is equal to 80.10 add 1.868 Kelvin. So this is degrees Celsius. And this is Kelvin. So we convert the delta T degrees Celsius is equal to delta T degree Kelvin. So we can just call that degrees Celsius. We get a TBS 81.97 degrees Celsius. So for dilute solutions, the expression for the freezing point we can use as follows. Delta Tm is equal to RT squared M naught over delta Hm hat, where delta H hat M is the heat of fusion of the pure solvent at melting point. So we can calculate delta Tm as 3.636 Kelvin, and we just subtract this. So we have Tms is equal to the normal temperature, subtract delta Tm that we just calculated, so Tms is equal to 5.53 degrees Celsius, take away 3.636 degrees Celsius because delta T Kelvin is equal to delta T degrees Celsius. So we have a Tms of 1.89 degrees C.